couple things to mention at this point. One thing that for a non-artist such as myself makes life a lot easier is if I don't try to draw the object that I'm interested in realistically. You can do what's called a point particle representation. So for example, the barbell that we were just talking about. If I just create that, just call that a point, that's fine. I'm gonna, that purple dot there, that's my barbell. And then from that, I can then start to put on the different forces acting on it. So in this case, weight downward. Well, of course, I always label it, put a little W there. And then we had, I think in green, I had the normal force, or the support force, right? And that's all I need. If I'm going to do a force diagram of that barbell, I don't need to draw a pretty barbell. All I need to do is put a point and then attach to that point the different forces that are acting on the object. Now, what forces have we dealt with so far, and which ones will we deal with? We've dealt with weight so far, and weight is what's called a force at a distance. Notice that the Earth pulls on anything that has mass, whether or not the object is in contact with the Earth, right? The Earth pulls on barbells, the Earth pulls on us, the Earth pulls on birds, and the Earth pulls on planes, and the Earth pulls on the moon, and the Earth actually pulls on the sun 100 million miles away. So things don't have to be in contact with the Earth in order for the Earth to have a gravitational influence on those objects. So gravity is considered to be a force at a distance, as are electromagnetic forces, which we're going to deal with later on in the course. But if you ever brought two magnets with the north poles to each other, they resist each other, they repulse each other, they repel each other. They don't have to be touching in order to influence each other's motion. Those are what are called forces at a distance, where they don't have to be in physical contact. Everything else, however, that we're going to be dealing with are what are called contact forces. For example, I can't lift a barbell without touching it. I can't just mentally think about it and lift the barbell. I have to be touching it. So applied forces are, or essentially pushes or pulls, those are contact forces, right? I can't push a desk across a floor by just thinking about it. I have to be in physical contact with the desk. Likewise, things like tension. You only have tension in a string or a rope or a chain if it's in contact with an object. A normal force, right? When you stand on a floor, as we're going to talk about, there's a normal force acting on you, but that normal force is only there when the floor is in contact with your feet. When you jump and you're in the air, the floor is no longer exerting a normal force on you. Only when you come back down is the floor exerting a normal force on you. And likewise with friction. Friction is a force it's a contact force. It's when two objects, two surfaces come together. When they're rubbing against each other, that's when you have friction. If I've got a plane flying over the ground, over Mississippi, Mississippi is not exerting any kind of force on the plane. Right? There's no tension, or there's no friction. And when the plane comes to land and the wheels come in contact with the airstrip, yes, then I have friction, because that's when they're in contact. So friction is a contact force.